suppose the concrete, before I use a video, and the students may watch it. So, in your opinion, so can you see something about concrete? So that's now, before you learned the class, can you use some words to describe that?
Good. The concrete is a mixture of cement, aggregates, and water. Yeah, mixed together. Then when it hardens, that's concrete.
Yeah, it's a mixture, right?
Mixture.
Okay. Yeah, thank you. And the other one want to see something? They have that.
Apart from the components that we talked about, there's also sand.
The same.
Sand.
Sand. Aggregate, they have the sand. Yeah. Okay.
And then together pure.
Mix it together.
Yeah,
Okay. Yeah, thank you. And what else? See, yeah, that's in the initials, the concept that concrete we mixed, they are just fluent, right? The fluent. And after several times, the concrete will have a strength. Right? This is also a character that we can use to describe the concrete, right? So the concrete has this character, and another is it's a mixture. Yeah, that's right. Yeah, that's true. Here, just like stone, concrete, but it's a man-made stone, and for the concrete, we know the cement like the Portland cement, and for aggregate, it has a divide. We divide in here is a fine aggregate. We name the sand, right? Sand, and the coarse aggregate is a gravel. So yeah, this is a fine aggregate. They are really small thing. And for here is a gravel. There's a rock, and also the bigger than fine sand here. For this picture shows the cement. Cement is a really complicated material, but we know just like glue something. They combine this together as cement. Also, so really important is the water. Water mix these things together, and there is a chemical process named hydration. Yeah, hydration. Yeah. So during this hydration, the concrete and the fluid state they come to the strength, become strong. They intact the chemically and bond together. And another something that we add in the concrete here is like the fly ash. These things they will improve the character of the concrete. Like it will to strong the strength, or some water reducing that. If we add these things on the concrete, they will make that the concrete do not need so much water. Or another the mixtures we use here. But mainly the concrete consists of the four things, the cement, the aggregate, the sand, gravel, and water. This is the main thing. And another is that we add in the concrete just to improve the temperature. We can not use these things. It's also okay. Also okay. Yeah.
So you mix cement with water. And
Cement to water, yeah.
yeah, just cement with water. That's not concrete.
Yeah.
It's not. Cement mixed with water.
Yeah.
Just cement.
Just cement and the water, these two things. But we can name this concrete, but there's a strength is not really high. Yeah, not very high. And these things also we do not want. We can name it. It's a concrete, but the strength is not really high. Yeah, but you know that for us to build buildings, the concrete it has a high strength. They need to resist the load. If we only use these two things, we will see it later. They will not have the high strength. It will break suddenly or something. Yeah. But in some not important numbers, yeah, we also use these things. Okay. Yeah, you see.
So all of these, when you're mixing them,
Mixing.
Yeah, so when you're mixing them, do they have specific proportions you have to like mix them in?
Sorry.
When mixing them together,
Yes.
do you have specific proportions you have to like mix?
You mean the ratio?
Yeah.
Ratio. Yeah, different ratio will have a different rate.
Okay.
Yeah, different rates. Like maybe occupied. This is occupied 30%, and this is 50%. But it will introduce in another course that material of the civil engineer. And here we just use a grade like C15 or C17. This grade means that we now use this concrete. The mixture, mixed ratio is okay. They can reach this strength. Yes, here. And for here, we just roughly introduce the concrete has this thing, and I do not care about how to mix this whole thing to reach this strength. Okay? Yeah. Here I want to explain. Yeah. And for here's let you to know roughly to know these four things that you to get the concrete. Yeah, this is in microwave view. And properties of wet concrete, like here is the ability to flow, right? For we get initial the concrete mixture listing together, they will flow, they easily flow. If we any sheet and pour the concrete in this sheet, they will come this sheet. And here is a test I want to introduce here to measure how, because just like the Wangzelen, right? You are the Wangzelen. Moil, just like moil step. We use a different ratios part to mix it. We will get different type the concrete, right? Here we use a slam test. Slam test to measure how the ability of this type of concrete to flow. Okay, so here I introduced this test. The process will be like this. This is the sheet we get here, and pour the concrete to here, and to full. There the full, and then we move this sheet, and of course it will slow, right? So because it's initial, they are wet, they are flow. Here we measure. For this shape we get it here. This is a ruler, and to measure this value. This is an index for us to judge or to see, to divide the different mixtures, the good or not, in this character, flow character here. Yeah, here's is a slam test for us to do, to know, or to measure the concrete good or not as flow character here. Yeah. And I want to know, in this semester, yeah, do you have the experiment class, like to mix this material or to do some experiment? No. And in previous semester, we have
Mayo.
yeah, Mayo. So, yeah, but I think it has, because yeah, we have a theoretical way to learn, but need to do some practice. Yeah, maybe you can suggest our college to write something.
We don't really know. We are still engineering experiments, but we don't really know what specifically that we doing.
You don't.
Most of them,
Civil engineering.
most of these will be announced in class. So if you want us to have it, we'll have it.
You need, but there's a difference. Like to carry this experiment, they should have another teacher. I mean, they familiar about these things. The teacher they organize because there are several tests. Maybe okay. I also will see to make the whole thing to be well. But here I just see maybe not you not get good impressed about this. But here, yeah, I introduced here is a slam test is a to used here to judge the character of the concrete floor. It's okay, right? It's okay. Yeah, this is the shape of the tools that we use. For here, we moved this shape. The concrete will like, yeah, and for this is good, right? This is good. So it means this is not good in flow, and for this is have good flow. And for there, the guys use the ruler to test, and different mix will have a different values in this, and we use these things. And here comes the question, right? Comes the question. Do you think, yeah, if this value bigger is a good, or it's the smaller is a good? Can you say something?
Bigger is good.
Bigger is good.
Smaller is good. Smaller is good.
Smaller is good.
There's always two options. Bigger.
Yeah.
Medium.
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 The question is between two.
Yeah.
Where is the middle?
The larger the bigger or the smaller.
Actually, yeah.
Why?
If it's small displacement, it means that it's so dry.
Yeah.
So dry.
Yeah, it can form some plates.
Yeah.
I said if it's big.
Again, if it's big, it's not very efficient. So it needs to be a medium.
Medium.
But the question was,
The question is,
Formulating.
which one option C except?
They're never understand. They're never understand.
Yes, I want to explain. Because we at before we said for concrete, when it's a floor state to come to strong, there is a hydration process, right?
Yeah.
Hydration process need water, right? Need water, and also in before the video, the guys also mentioned for the concrete, if we leave it in a water environment, the smooth or the strength will be higher. Yes, it's right that, yeah, it's just as Zhang Hun said, the medium is good. Because come to reality, come to no, listen to me, not listen to me. Because when we construct the structure, right? If it's a really good in floor, that means it will form the mold. Can you get my point? Because here we use some wood to build the mold, and then we pour the concrete in here. If it's wet, it's good at floor. That means there will not the bar will not yeah. It means there will be full, not empty of something. Because if we just like the dry concrete here comes, there will have the surface will not smooth, right? Surface will be not smooth. So here we want the concrete at initial stage will have a good flow state, yeah. But after its hydration, right? Hydration process, we want the concrete has a strong strength, right? Strength, yeah. So the flow state, it means we need to pour a lot of water, yeah, in the concrete to mix. But it will need more time for concrete hydration, right? Hydration. And if we so here for civil engineer or some scientists, they use some the mixture, right? Yeah, here's like a mixture to improve the concrete. And initial, they will have a good flow character. And after that, the hydration and this admixture, they will quickly hydration. They will quickly get strength. So we divide it in different stages. Okay? Different stage. This is the time. And first, at the initial stage, we need it's a good flow state. So means the slab should be the ruler value should be higher, be larger, right? But after the initial, we want the slab value should be small, the high hydration. So different state we need different characters here. So use a medium maybe is okay, but I hope the student can divide that to realize that different stage we need the different different slab value. So we know so for the concrete at last here exactly to test. This one is a really the large is the value is too large. Yeah. So maybe there has a recommend in code they will recommend the range will be between a range value for you to take reference, and when to judge the concrete is good or not. Yeah. So it's in the medium value range. Okay, so here's I think I explained it. If you're not still confused about this mathematics after class, you can communicate with me. I will try my best this slam test. And okay, concrete we know, and now we want to see what's reinforced concrete. Can you see something?
Reinforced.
Yeah, reinforced concrete. What's the difference between the reinforced concrete and the concrete?
Reinforced concrete is one where you add some, like, let's say, some steel to it, to make it, yeah, some steel or iron, anything, to make it stronger. So it's stronger than the normal concrete.
Yeah, sometimes the really well. Touch the main point, right? Because the reinforced concrete here is different with the concrete is here we use steel bar, steel bars in here. And the why here we use steel bar or some steel materials, also not steel like fiber. Fiber is a new material that glass fiber or something. But here we need the reinforced concrete that here use steel bar to improve concrete character. But how to improve concrete that we need to know here. Look at the picture. The reinforced concrete uses a steel that we also see this in our common life, that we see the place that we use so much steel and pour concrete together, and together the reinforced concrete. Yeah, and after the hydration process, yeah, it's smooth. And before, things will look like this: steel bars. And why we used steel bars in concrete? That's because the concrete they are has a high compressive strength. It means we give the pressure. They good at the compression strength. But if we give the tension in concrete, they will have a crack. They are weak in the tension. And these things will be improved if we use the steel bars in the concrete here, in the concrete. Because steel, they both good at the compressive strength and also good at the tensile strength. Yeah. But here we need to realize concrete is a cheap, right? For material, it's a cheap. But for steel, it's expensive. Yeah. So here, the steel engineers, they use like for a beam, right? For a beam, they are reinforced concrete. They will use steel bars at the bottom of the beam. Yeah, bottom of the beam. And because at this situation, we learned structural mechanism, right? If there's the beam under the load, right, they will have a deformation. Yeah. For deformations, I think the teachers will not mention the section of the beam, how it suffer from the load, right? They only the mechanical teacher, they only teach you that under the load they will have deformation and let you to calculate how the deflection or the moment or something, right?
Mm.
Yeah, but for this class, yeah, for the concrete, we will to analyze more further to understand. For section, because in reality, right, they have the dimension, right? Dimension under the load. In this part, it will under the compression, and in this part, because it's in the bottom, right? Bottom, yeah, in tension. So. ION. Sorry. Sorry. Yeah. Oh, under the load, yeah, there is real compression, and this is the tension, right? This is the tension, and we for if there is a no steel bars, right? No steel bars, only the concrete, yeah, under the load, right? Under the load. That means in this part, right? This part, definitely it will reach his tension's limit strength of the concrete. It will reach at that value. If it to reach to this values, it will break. For concrete, it will break. So here's I roughly introduce here that we use the steel bars because steel bars is good at tension. They can resist the tension. So yeah, so they will improve the concrete. Yeah, so but because of it's expensive, right? Expensive, so we do not use more or much of the steel bars in here. Because in another class that you will learn steel structure. Steel structure. They may introduce the whole material, whole the beam, use the steel. It's also okay. Yeah, it's also okay, but it will expensive. Yeah. So for reinforced concrete, we use the concrete compression strength or steel strength, steel strength here. Yeah, that's the reason why we propose the reinforced concrete here. Yeah, okay. Yeah, there's a figures in last sheet. For these figures, there's a no steel bars under the load. The crack will develop at the bottom of the beam, and quickly the beam filled. But if we use the steel bars, for the tension to resisted by the steel bars, it can prevent the crack development. So they will improve the character of the beam. Yeah, this is the guides do the test to get the values. This is for the columns, right? Columns. If only the concrete or if we add the steel bars, they also do measure the values of the force. Force here we see, and the steel bars use the steel bars have a good resistance. They have a good character. They can suffer bigger load. Yeah, for here's we just roughly know the difference between the concrete and the reinforced concrete. Yes. Here's we use a example that to see. This is a plain concrete. The spin is like this values. Because the beam, it has a section like this. Later, I will introduce how to calculate this beam, but here's only to let you roughly see it. This is the steel bars used because the section size is the same, only different that in this beam we add the steel bars, and the failure mode also different. For the concrete, they are brittle. They will break suddenly. But here's, if we do the test, we will see some crack occurs on the beam. So the failure mode is different. Here, I hope everyone has a roughly to see. And for here, so we measure the load. That for this beam, they only can suffer the 4.4 kilonewton, and for this beam, they can suffer 62.5. So really, this value is larger than this one, right? Larger than this one. So and the steel bars in the beam can really to improve the concrete character here. And this is the result right here and here to describe this test. We can realize that load capacity also 14 times higher for the plain concrete beam. There's no obvious no buffer because it grows suddenly. For the steels used in the beam, it will have a drop in that. You do not grow suddenly because the steel it has a yield. They have this material. We divide the different states of the for the steel bar suffer the load. So here's introduced here. I think everyone knows the difference between reinforced concrete. Why in our common construction that we prefer the reinforced concrete or do not use the plain concrete directly? That's the reason. Yeah, okay. For here's, we know two things, concrete and reinforced concrete. And now let's talk about, if you as a civil engineer let you to construct or let you to design a building. So how you do this? Yeah, I think the Ziqiao maybe have a really good experience, right? Can you see something? Yeah, if some client or some others ask you, you just imagine, okay? Just imagine. Now you are really a good civil engineer. Yeah, sit here, and the person comes and he asks you, can you design buildings or something? So how you will do for design, for structure design? If you, here's let's discuss. Can you say something? Talk about the design process. Because our class is a principle for concrete structure, and in the next semester we will learn the construction design. Right? So it's we can discuss mixed it together and let you have the whole to realize that of the design process. Yeah, just a talk, not a method. for design. Design process. Yeah, if you are a civil engineer, I see at first, if you design process, design a structure, of course, we will revise several times, right? It's not like a linear process, because some guys can't ask you that I want to build a factory or I want to build a hospital, that you design, you will draw something, and at first you will give him to see your drawings, right? Drawings, and then we do some calculation to details that how the size of the beam, how the size of the beam, and the next thing, right? Yeah. And if we decide the size, right? Decide the size of the beam, decide the size of the columns, and then we will ask some factory to make the concrete. Right? And the concrete comes, and we will do some tests to know if the concrete can reach our requirement or not. If it's a requirement satisfies the requirement, and then we use this concrete pour in the mold. And after hydration, we will move the mold, then the building is constructed, right? So roughly, the process like this, right? Yeah. So for this is the design process. Is for big to come to small part, and then to the detail. This is the design process. But for us to learn things, we need to begin to material and to know, and then we will design the dimension, the dimension of the beam, the dimension of the column, and then use a structural mechanism to know if the hospital, the load will be different, way higher than the dormitory. For learning is small to bigger, to big, and to big. And for design, they are big, come to small. I'm not sure that you can get my point or not. What is for design, because it's a 从大到小，从大到小。And for learning, 从小到大。The process just upside what I want to express here. Yeah. Okay.
On paper, it's small things.
Yeah. Okay. Now today's class is over.
Big things. Big things.